Hello, I apologize about the noise, this thing is quite loud, but this is my version of a mechanical integrator. Back before we had computers that were able to calculate integrals automatically, on Navy warships when they had to calculate trajectories and other applications as well, they would have what I believe was called a planimeter, or also known as a mechanical integrator. So the components of this, we have this module here, the turntable, which consists of this turntable, which is spinning at a constant rate. And this turntable is on a platform, which is allowed to move left and right. And that left to right motion is controlled by a stepper motor, which is very able to precisely move it a specific distance. Up on top, I have a disc that sits on top of the turntable. And as the turntable moves left and right, we can see that the disc begins to turn at faster rates depending on how far out it is. Essentially what is happening is the linear motion here is being translated to the slope of the graph, and as this moves further left, the slope becomes further and further negative, and as it moves further right, the slope becomes further and further positive, and this wheel acts as a mechanism of plotting that value. I have a rotation sensor on this side, which is able to count the number of rotations that this goes through, and it's able to keep track of that along with all the electronics that make this work. So on my computer, currently this is moving simply linearly left and right. Once it hits the left side, it begins to move linearly right and then back. So the slope of this is basically straight up and down, or not straight up and down, but basically linear fashion going up, and then as soon as it hits amplitude, it goes back down, essentially like this. So we can think of that as a linear function, which means that when we take the integral of this, we would expect it to be some sort of exponential function. If we look back over on my computer, which is plotting the values, that's exactly what we see. So we can actually see that the slope here is decreasing linearly, it's decreasing, and then once we pass this point, right here, the slope is no longer decreasing, but now the slope is increasing, which is what we can see here. The slope begins coming back up. And we can see that since this is taking the integral of the function, the linear slope, which is expressed in the motion of the left and right motion of the platform, we can see that it translates to a exponential function of sorts, even though it's not exactly precise because I didn't have the correct materials to build this to the level of standard that's needed for such a precise measurement. This was simply just a demonstration to show that this is able to show some sort of exponential function from a linear input. So all this motor is doing is it's moving it left and right at a constant rate, whether positive or negative, and we can see that on the output of the function. We get an approximately exponential shape, which matches up with what we would expect. Since this is moving linearly, it is adding rotations or subtracting rotations at the exponential rate. If I had programmed it for a sine wave to move the left and right axis, the turntable, according to a sine wave, we should see approximately a cosine wave over here, or perhaps a negative cosine wave actually. But some sort of sinusoidal wave that's shifted by some phase shift. And similarly with any function that I program to move left and right, we should see in the output of this rotation sensor an approximate integral of the function. So yeah, that is how this works. I've linked the YouTube video. My design is very similar to a YouTube video I watched. I basically designed it myself, but the design is entirely inspired from a YouTube video I watched, which I've linked in the PDF, so I don't want to take credit for that. I simply just made the project, but I got the idea from an online video that showed it, and that person's version is much more precise and is made with a much better quality, and is able to show much more precise measurements than mine, which shows just a rough approximation of something we would expect. So yeah, that's my honors project.